Good day, everyone. My name is Jolly Dongkoy, and for today, my discussion was all about Vernier caliper and metric reading. Objectives. After the discussion, the students will be able to first identify the parts of the Vernier caliper and its functions. 2. Identify how to read Vernier caliper using metric reading. 3. Get the accurate measurement or the final reading using vernier caliper. Fourth, to determine the distance between two opposite sides of a surface. And lastly, to identify the zero error of vernier caliper and measurement. Before I proceed with my discussion, I have here my motivation. As you can see, there is a picture on a vernier caliper, and I want you to solve the jumbled letters for you to be able to identify the parts of the vernier caliper and its name. I will give you 10 seconds to answer the parts of the vernier caliper. Okay, are you ready? So what do you think the name of the parts on the number 1? Correct. That part is the main scale. And how about the number 2? Correct. The number 2, that is the Vernier scale. And number 3, that is the sliding jaw. Number 4 is the lower jaw. And the number 5 is the upper jaw. And the number 6 is the lock screw. And number 7 is the depth rod. And lastly, the number 8 is the thumb screw. Those are the parts of the vernier caliper. So what is vernier caliper? A vernier caliper is a dimension measuring instrument that is used to accurately measure not only the internal and external dimensions of an object, but also its depth. The instrument, which equipped with a fixed jaw and a movable jaw that moves along a graduated scale, can measure to an accuracy of 100th of a millimeter. A vernier caliper is for measuring the distance between two opposite sides of a surface. We can measure the internal and external of a dimensions and even the height of an object with accuracy. Uses of vernier caliper. The core uses of vernier caliper is for measuring the distance between two opposite sides of a surface. We can measure the internal and external of a dimension and even the height of an object with accuracy. It can measure up to 100th of a millimeter. There are some sectors using vernier caliper. First is the science lab. Science lab used vernier caliper for studying the expansion of materials due to differing temperatures in order to find out their properties. It is used to measure various equipment in order to fit in properly. They are also helpful for measurements of regular and irregular shaped objects from the interior or the exterior. Second is the medical purposes. The medical and surgical industry depends on this device extensively because the dimension of instruments have been measured in order to be ideal for surgery. Steel industries. By checking the dimension of byproduct in order to ensure the desired standards are met, uses of vernier caliper come in highly recommended. It is used to measure the width and even the height of various objects. It helps in measuring holes, the width of pipes, and the circumference of metal beads, and many more. Aerospace industries. The use of this device will ensure safety standards are met, along with precision in the use of small parts which helps for flying. In educational sector, In school, in engineering institutions, the use of this instrument helps students to gauge various other instruments and objects used in physics or many other fields, and also helps in rectifying zero error. Using this instrument to measure outside and inside dimension of a cylindrical shape, objects are on one of the few experiments in modern physics. History of Vernier Caliper. A caliper without a Vernier scale originated in ancient China as early as the Qin Dynasty or AD 9. The first caliper with a secondary scale, which contributed extra precision, was invented in 1631 by the French mathematician Pierre Vernier in 1580 to 1637. The term Vernier was popularized with the French astronomer Jérôme Lalande in 1532 to 1807 through his treatise De Astronomie. In some languages, a Vernier scale is called Nunez, after Portuguese mathematician, cosmographer Pedro Nunes, a Latin Petrus Nunez in 1502 to 1578. In English, this term was used until the end of 18th century. Nunez now refers to an earlier instrument that Nunes developed. So what are the parts of the vernier caliper and its functions? We have the upper jaw. Upper jaw is the two upper jaws that is used to measure the internal measurement such as the diameter of a hole or slot. And the lower jaw, it is the lower jaws and the longer jaws that are used for measuring external diameter and overall length of an object such as the width, length, and diameter. The depth measuring probe or the depth rod, it is a slender stick-like structure used for measuring depth inside of an object. It is attached to the movable arm and moves along with it. The Vernier scale. A Vernier scale, it is the smaller scale attached to the main scale and can move along the main scale as the jaws are open and closed. The main scale, it is the large scale which runs along the body of the vernier caliper, and it is graduated either in centimeter and millimeters. Sliding arm, it is the movable arm carries the vernier scale. Locking screw. It is for holding the arms at a particular place where taking measurement. This helps in locking the movable arm at one particular place for attaining higher accurate measurement and for reducing the error rate. Thumb screw. It is located at the bottom of the vernier scale. Its purpose is to provide grip for the user to slide the jaws easily and adjust the position. A vernier caliper has two main scales. First, the main scale that runs along the beam of the caliper on a metric vernier caliper. The main scale is graduated in centimeter and millimeter. And the second one is the vernier scale or secondary scale. It is the sliding scale which moves over the main scale whenever adjustable arm is moved. Both metric and inch measurement are provided on both of the scales. It also adds an extra degree of accuracy to measurement on the vernier scale. The smallest increment on the main scale is further divided. Each scale is divided into 10 equals. So how to read the metric version of vernier caliper? Regarding to the metric version of vernier caliper, there are three kinds of graduations. First, 0.1 mm. Second, 0.02 mm. Third, 0.05 mm. For the metric version of vernier caliper, each graduations on the main scale is 100 mm. Every 10th graduation is numbered in sequence. 10 mm, 20 mm, 30 mm, 40 mm, 50 mm, so on and so forth until the full range of the scale. To provide direct reading in millimeters, the Vernier scale is graduated in 50 parts. Each represent 0.02 mm. Every fifth line is numbered in sequence in 0.10 mm, 0.20 mm, 0.30 mm, 0.40 mm, 0.50 mm, providing for direct reading in hundreds of millimeters. The Vernier caliper last count's formula is calculated by dividing the smallest reading on the main scale and the total number of division on the Vernier scale. Last count, or the LC of Vernier caliper, is the difference between one smallest reading of Vernier scale, which is 0.1 mm or 0.1 cm. What are the steps for reading the metric version of Vernier caliper? So the first step is you need to look at the main scale. When taking measurement, you should first read the value on the main scale. On a metric Vernier caliper, this will be given in millimeters. The smallest value that can read from the main scale is 1 millimeter. It is indicated by a single increment. And the value of the main scale is the number immediately to the left of the zero marker on the Vernier scale. In this instance, this value is 27 mm in the main scale. Second is look at the Vernier scale. The Vernier scale of a metric Vernier caliper has a measuring range of 1 mm. In the example, we will be looking at the Vernier scale, and it is graduated in 50 increments. Each increments represent 0.1 mm, 0.02 mm. However, some Vernier scales are graduated in 20 increments, with each one representing 0.05 mm. When reading the Vernier scale, identify the increment that lines up the most accurately with an increment on the main scale. This value will make up the second part of your measurement. In the example, the increment of both scales coincide at the 0.8 mm on the Vernier scale. Third is add both values together. To get your total reading, you need to add both the value from the main scale and the value from the Vernier scale together. Like for example, the main scale reading is 27 mm and the Vernier scale reading is 0.8 mm. So the main scale reading plus the Vernier scale reading is equals to 27.8 mm. So the distance between the jaws of the Vernier caliper is 27.8 mm. In a Vernier caliper, we have direct and indirect reading. For direct reading, these are the most common. The indicating scale is constructed so that when its 0 point coincides with the start of the data scale, its graduation are at slightly smaller spacing than those on data scale, and so none but the last graduation on the data scale like for example, the smallest reading on the main scale is divided by the number of division on the Vernier scale. So the smallest reading on the main scale is 1 mm, divided by the 10 division, which is the Vernier caliper has 10 division. So 1 mm divided by 10 is equal to 0.1 mm, and that is the example of a direct reading. So the last count is 0.1 mm. For indirect reading, an example, as you can see that The one main scale, there are 20 divisions. And for us to be able to get the value of each division on the main scale, we need to subtract. Like for example, 20 division minus 10 is equals 10 divided by the 20, which is the number of division on the main scale. So we have 1 over 2. 1 divided by 2 is equals to 0.5 millimeter. 0.5 millimeter is the value of each division on the main scale. And for us to be able to get the value on the Vernier scale, we need to divide the 0.5 divided by 25, the number of division on the Vernier scale, for us to be able to get the less count of 0.02 millimeter. Okay, in a Vernier caliper, there are 3 graduations. So let's now go for the graduation of 0.1 millimeter. For us to get the less count of 0.1 millimeter, we need to get the smallest reading on the main scale and divide it by the number of division on the Vernier scale. So we have the smallest reading on the main scale is 1 millimeter. And the total division on the Vernier scale is 10 division. 1 millimeter divided by 10 on the division of the Vernier scale, so we have 0.1 millimeter. So our less count is 0.1 millimeter.
As you see here, the smallest reading of the minimum reading on the main scale is simply this value, and this value simply, it is 1 mm. So the smallest reading on the main scale is 1 mm. And regarding the number of divisions on the Vernier scale, this is the Vernier scale, and if you count for number of divisions, you will count for 10 divisions. So now we can compute for the least count of this caliper by dividing 1 mm by 10 divisions. So the value of the least count is simply 0.1 mm. So this is the way how this value, which is 1/10 of a millimeter, comes. Let's now understand how to read this type of Vernier caliper. As you see here, in the top we have the main scale. So this scale is called the main scale, and below here we have the Vernier scale. So first we should read the main scale. In order to read the main scale, we should consider the 0 line on the Vernier scale as the reference for reading the main scale. As you see here, the last line on the main scale before the 0 line on the Vernier scale is this line, and this line is simply, it is 21 mm. So the main scale reading is simply 21 mm. Now we should read the Vernier scale. So in the Vernier scale we have 10 lines. One of these 10 lines should line up with one line on the main scale. So if you check, you will see that line number 4 on the Vernier scale lines up with one line on the main scale. So line number 4 on the Vernier scale is read as 0.4 mm. So the reading of the main scale is 21 mm, and the reading of the Vernier scale is 0.4 mm. So the total reading for this caliper is the summing up of these two values. So we have 21.4 mm.
Example of graduation in 0.1 millimeter. As you can see on the picture, that for us to be able to get the value on the main scale, we need to check the 0 on the Vernier scale as our reference to get the value on the main scale. As you can see that the 0 on the Vernier scale was on between the 4th line and the 5th line on the main scale. So that means since the 0 on the Vernier scale did not reach on the 5th line, that means the value on the main scale is 4 millimeter. And for us to get the value on the Vernier scale, we need to look the line that coincides on the Vernier scale and to the main scale. So as you can see on the red line, that is the lines that coincide on the main scale and the Vernier scale. So the value of that line is 0.8 millimeter. And to get the final reading, we need to add the main scale reading plus the Vernier scale reading. So we have 4.8 millimeter as our final reading. In example number 2, the value of the main scale is 10 because the 0 on the Vernier scale did not reach on the first line on the main scale. So that means we have the main scale reading of 10. And for the Vernier scale, as you can see that the 7th line on the main scale and the Vernier scale coincide to each other. So we have the value of the Vernier scale of 0.7 millimeter. So our final reading is 10.7 millimeter. Okay, I want you to answer this activity using the graduation of 0.1 millimeter. I will give you 5 seconds to answer for the number 1 and number 2. Okay, are you ready? Okay, for the number 1, for you to get the value on the main scale, you need to look the 0 on the Vernier scale as your reference. So you see that the 0 on the Vernier scale stopped on the 44th line on the main scale between the 45th line. And since the 0 Vernier scale did not reach on the 5th line, so that means our Vernier scale reading is 44 millimeter. And how about the Vernier scale reading? So you see that the 6th line on the Vernier scale is coincide on the main scale. So that means we have the value of the Vernier scale, which is 0.6 millimeter. So 44 millimeter plus 0.6 millimeter, we have the final reading of 44.6 millimeter. And how about the number 2? The number 2, the 0 on the Vernier scale did not reach on the first line on the main scale. So that means that we have the main scale reading of 10, while the Vernier scale reading, as you can see that the red line is coincide on the 7th line on the Vernier scale and the main scale. So we have the reading of the Vernier scale, which is 0.7 millimeter. And to get the final reading, we need to add the main scale reading plus the Vernier scale reading. So we have the 10 millimeter as a main scale reading, and we have 0.7 millimeter as our Vernier scale reading. So we have a final reading of 10.7 millimeter. In the last count of 0.02 millimeter, the smallest reading which can be accurately measured with a Vernier caliper is called the last count, and it is also known as the Vernier constant. The difference between the main scale division is 1 millimeter, and the Vernier scale division is 50 millimeter. So for us to get the last count, we need to look for the smallest reading on the main scale, which is 1 millimeter, while the number of divisions on the Vernier scale is 50 divisions. So 1 millimeter divided by 50 division is equals to 0.02 millimeter. So 0.02 millimeter is our last count. So each value on the Vernier scale is 0.02 millimeter.
Simply the division of the smallest reading on the main scale by the number of division on the Vernier scale. So regarding the smallest reading on the main scale, simply this is the smallest or minimum reading on the main scale, and this value is simply 1 mm. So the smallest reading is known. Now we need to determine the number of division on the Vernier scale. This is the range of the Vernier scale. If you count for the number of divisions on this scale, you will count 50 divisions. So now we can compute for the LC for this caliper. So it's equal to 1 mm divided by 50, which is equal to 0.02 mm. So this is the least count of this caliper, which is 0.02 mm. In order to read the graduations of the Vernier scale, we should take this value of the least count into consideration. Let's understand how to read the Vernier scale graduations. This is the 0 line on the Vernier scale, so it's read 0. The first line, it's read as 0.02. The second line is read as 0.04. The third line is 0.06, 0.08. This line is line 0.10 mm. So this is the way. This is 0.12, 0.14, 0.16, 0.18. This is line 0.20 mm. 0.22, this line is 0.30, etc. So as you can see here, we read the graduations of the Vernier scale by the multiples of the 0.02 mm. This caliper is of the same least count, simply because the number of graduations on the Vernier scale is 50. So we consider this line to be the reference for reading the main scale. The last line before this reference line is this line in red. So this line is line number 18 mm. So this is the reading of the main scale. It's 18 mm. Now we should read the Vernier scale. We should search for one of these 50 lines, and this one line should lines up with one line on the main scale. Here we have an enlarging of the location of the aligning. So as you see here, this line is aligning with the above line on the main scale. See that the graduation or the scale below is scale number 2, which is the Vernier scale, and the scale which is above is the main scale. So we should read this line, take care that this number here refers to this line, and this line is 0.30, so this line is 0.32. So this is the location of the aligning. So the reading of the Vernier scale is 0.32. So the reading for this caliper is simply 18 plus 0.32, which is equal to 18.32 mm.
For example, you see that the 0 line on the Vernier scale did not reach on the 19th line on the main scale. So that means we have the value of the main scale, which is 18 millimeter. And for us to get the value on the Vernier scale, we need to look which line coincide to each other. So you see that the 31st line on the Vernier scale coincide on the main scale. So we have here the Vernier scale reading of 0.32 millimeter. Main scale reading plus the Vernier scale reading is 18.32 mm as our final reading. For the number 2, you see that the 0 on the Vernier scale stops on the 22nd line on the main scale. So that means we have 22 mm as our main scale reading. And for the Vernier scale reading, you see that the third line on the Vernier scale is coincide on the main scale. So we have the value of 0.06 millimeter. So main scale reading plus the Vernier scale reading is equals to 22.06 millimeter as our final reading. Okay, I want you to answer this activity using the graduation of 0.02 millimeter. I will give you 5 seconds to answer for number 1 and number 2. Okay, you see that the 0 on the Vernier scale did not reach on the second line on the main scale. So that means we have the value on the main scale of 1 millimeter. And for us to get the value on the Vernier scale, we need to look that line coincide to each other. So you see that the 63rd line on the Vernier scale is coincide on the main scale. So that means we have the value of 0.66 on the main scale, on the Vernier scale. So we have the final reading of 1.66 millimeter. And for the number 2, you see that the 0 line on the Vernier scale did not reach on the 19th line on the main scale. So that means we have the value on the main scale, which is 18 millimeter. And our Vernier scale reading is coincide on the 31st line on the Vernier scale. So we have the value of 0.32 millimeter as our Vernier scale reading. As a final reading, we have to add the main scale reading, which is 18 millimeter, plus the Vernier scale reading, which is 0.32, so we have the final reading of 18.32 millimeter. Okay, for this one, we still have the less count of 0.02 millimeter, but the division on the Vernier scale is only 25 divisions. And for us to get the less count, we should check first the value of the main scale. For us to get the less count, as you can see that the number of divisions on the main scale is 20. So we need to subtract for us to get the last count. 20 minus 10 is equals to 10 divided by the number of division on the main scale, which is 20. So 10 divided by 20 is equals 1 over 2. 1 divided by 2 is equals to 0.5 millimeter. 0.5 millimeter is the last count of each division on the main scale. And for us to get the value of the Vernier scale, we need to divide the 0.5 millimeter to the number of division on the Vernier scale, which is 25 divisions. So 0.5 millimeter divided by 25, the number of divisions on the Vernier scale, so we have the last count of 0.02 millimeter. Example number 1. You can see here that the 0 line on the Vernier scale stops between the 54th or the 4th line and the 5th line on the main scale. And each graduation or each value on the main scale is 0.5 millimeter. So that means we have a 52 millimeter as our main scale reading. And for us to check the value on the Vernier scale, you can see that the 21st line on the Vernier scale is coincide to each other. And for us to get the value on the main scale reading, the 21, we need to multiply that 1 on the 0.02 as the last count for us to get the value of the Vernier scale. So 21 multiplied by 0.02 is equals to 0.42. That is the Vernier scale reading. So main scale reading plus the Vernier scale reading, so we have 52.42 millimeter. For example number 2. As you can see that the 0 on the Vernier scale stopped on the second line on the main scale. And each division on the main scale is 0.5 millimeter. So we have the value of the main scale, which is 11 millimeter. And the line that coincides on the Vernier scale is the 17th line on the Vernier scale. Again, for us to get the value of the Vernier scale, we need to multiply it by the last count. So 17 multiplied by 0.02 is equals to 0.34. The value on the Vernier scale is 0.34. So the main scale reading plus the Vernier scale reading, we have the final reading of 11.34 millimeter. In this activity, I want you to answer this using the graduation of 0.02 millimeter. I will give you 5 seconds to answer the number 1 and number 2. Okay. You see that the 0 line on the Vernier scale stops between 7 and 8 line on the main scale. And we have the value of each division, which is 0.5 millimeter in the main scale. So that means we have the value of the main scale is 43.5. And on our Vernier scale reading, you can see that the 5th line is coincide on the main scale. So 5 multiplied by 0.02 is equals to 0.1. That is the value of our Vernier scale. So the main scale reading plus the Vernier scale reading is equals to 43.6 millimeter. How about the number 2? You see that the 0 line on the Vernier scale stops on the 6th and 7th line on the main scale. So since the 0 on the Vernier scale did not reach on the 7th line on the main scale, so that means we have the value of the main scale reading of 13 millimeter. And for us to get the value of the Vernier scale, we need to get the line that coincide to each other. You see that the 20th line on the Vernier scale is coincide on the main scale. And for us to get the value on the Vernier scale, we need to multiply the 20 to the last count of 0.02 for us to get the value of the Vernier scale. So 20 multiplied by 0.02 is equals to 0.4. 0.4 is our Vernier scale reading. For us to get the final reading, we need to add the main scale reading plus the Vernier scale reading, which is 13.4 millimeter is our final reading. So we have here the last count of 0.5 millimeter. So the smallest reading on the main scale is 1 millimeter divided by the number of division on the Vernier scale. So for 0.05 millimeter, we have here the 20 divisions on the Vernier scale. So 1 millimeter divided by 20 divisions on the Vernier scale, so we have 0.05 millimeter as our last count. Each division on the mains or the Vernier scale is 0.05 millimeter.
Compute for the least count of any vernier caliper, and this formula states that the LC is equal to the smallest reading on the main scale divided by number of division on vernier scale. So as you see here, this is the smallest reading or minimum reading on the main scale, and this value is simply 1 mm. So the smallest reading on the main scale is 1 millimeter. Now we need to determine the number of division on vernier scale. This is the range of the vernier scale. If you count for the number of divisions in this scale, you will count 20 divisions. So now we can compute for the LC of this vernier caliper by dividing 1 mm by 20. So the least count for this caliper is 0.05 mm. So this is the formula that we can simply use in order to determine this value, which is called the least count or resolution. Now we need to understand how to read the vernier scale graduations. This line, which is the 0 line on the vernier scale, is read as 0. This line, which is the first line, is read as 0.05 mm. This line is 0.10 mm, 0.15, 0.20, 0.25, 0.30, 0.35, 0.40, up to this is 0.90, 95, and this is the 0 or 1 complete millimeter. So this is the way how to read the vernier scale by knowing the value of the least count. Let's understand how to make the reading for any caliper from this type of least counts. So as ordinary, we consider the 0 line on the vernier scale as a reference for reading the main scale. So the last line on the main scale before the 0 line of the vernier is this line. So the reading of the main scale is reading this line, and this line is simply line number 13 mm. So this is the reading of the main scale. Now we should read the vernier scale. We have here 20 equal separated lines. One of these 20 lines should line up with one line on the main scale. So you can check for this line. So this line lines up with one line on the main scale. So this line is read as 0.65 mm. So now we can simply take the whole reading for this caliper by adding the main scale reading and the vernier scale reading. So 13 plus 0.65 is equal to 13.65 mm.
So in the example, for us to get the value of the main scale reading, we need to check the 0 on the Vernier scale as a reference to get the value on the main scale. So you see that the 0 on the Vernier scale stop between the third line and the fourth line on the main scale. So that means since the 0 on the Vernier scale did not reach on the fourth line, we have the value of the main scale, which is 13 millimeter. And for us to get the value on the Vernier scale, we need to check the lines that coincide to each other. And each value of the Vernier scale division is 0.05. So we have here the value on the Vernier scale is 0.65. So we have the final reading of 13.65 millimeter. And for number 2, you see that the 0 on the Vernier scale stops on the 5th line on the main scale. It did not reach on the 6th line. So that means we have the main scale reading of 75. And to get the value of the Vernier scale, we have to look which line coincide to each other. So you see that the 4th line on the Vernier scale coincides the main scale and the Vernier scale. So that means we have the value of Vernier scale, which is 0.40 millimeter. So our final reading is 75 plus 0.40 is equal to 75.40 millimeter. In a Vernier caliper, we have zero error. When we say no zero error is a precise arrangement of the main scale and the Vernier scale so that the zero of both scales fit each other or coincide. This is when the jaws of Vernier caliper are brought into contact and the zero of the Vernier must coincide with the zero on the main scale. Otherwise, the instrument has an error scales or zero error can be negative or positive. So this is when you close the two jaws of a Vernier caliper, you will see that the zero on the main scale and the zero on the Vernier scale must coincide to each other for us to be able to determine that the zero error. So you see on the picture that the zero line on the main scale and the zero line on the Vernier scale is coincide to each other. So that means there is no zero error. In positive zero error, if the zero of the Vernier scale is to the right side of the zero on the main scale, then the zero is positive. This occurs when the zero on the Vernier scale is to the right on the main scale when the two jaws are in contact. And to take the precise value for the measurement we are taking, we have to subtract the value of the positive zero error from the obtained measurement. So like for example here, as you can see that the zero line on the Vernier scale was on the right side of the main scale. So it is a positive zero error. So when we see that, so the main scale reading is positive 0. Since the 0 on the Vernier scale was on the right side on the main scale when the two jaws are in contact. And our Vernier scale reading, as you can see that the 6th line is coincide to the main scale. So we have here the positive 0.60 millimeter is our Vernier scale reading. So main scale reading plus the Vernier scale reading is equal to 0.60 millimeter as our final reading. Okay, in this activity, I want you to answer using the graduation of 0.1 millimeter and look the zero error on the picture. I will give you 5 seconds to answer this activity for number 1 and number 2. Okay, for number 1, you see that the 0 on the Vernier scale was on the right side on the main scale when the two jaws are in contact. So that means it is a positive zero error. And the value on the Vernier scale, as you can see that the 6th line is coincide on the main scale. So we have the positive as our main scale reading and our Vernier scale reading is 0.6 millimeter. So, the final reading is positive 0.6 millimeter. And for number 2, you see again that the zero line on the Vernier scale was on the right side on the main scale. So it is a positive zero error. And the third line is inside on the main scale, so we have the value of Vernier scale, which is 0.3 millimeter. So the main scale reading plus the Vernier scale reading, we have a positive 0.3 millimeter. For negative zero error, this occurs when the zero on the Vernier scale is to the left side on the main scale when the two jaws are in contact. And to take the precise value for the measurement we are taking, we have to add the value of negative or the positive zero error to obtain a measurement.
So because we have a negative zero error, so we should move in this way. So as you see here, this line on the Vernier scale lines up with one line on the main scale. But how to read this value of this line or this error? We should read it in this way. So this is the value of the zero error, which means that the last line, we consider it to be line number 0. This line will be line number 1, which is 0.10 mm. And this line will be line 0.20 mm. So in this case, the value of the zero error is simply minus 0.20 mm.
So as you can see here in this example, that the zero line on the Vernier scale was on the left side and the zero on the main scale. So that means it is a negative zero error when the two jaws are in contact. And by reading the value on the Vernier caliper or in the Vernier scale, we need to read it in reverse. So on the 10th line, it would be the 0, followed by 1, 2, 3, 4, 5, 6, 7, 8, 9. An example here, as you can see that we have the negative zero error on the main scale reading. And the value on the Vernier scale reading, as you can see, is 0.20 millimeter. So the main scale reading plus the Vernier scale reading, we have the negative 0.20 millimeter in the final reading. So I want you to answer this activity and find the zero error using the graduation of 0.1 millimeter. I will give you 5 seconds to answer for number 1 and number 2. Okay, for number 1, what do you think is the error in the picture? So you see that the 0 on the Vernier scale was on the left side and the 0 on the main scale. So that means it is a negative zero error. And for us to get the value in the Vernier scale, we need to read it in reverse. So as you can see that the 6th line on the Vernier scale was coincide in the value of the main scale. So we have the negative zero error and the value on the Vernier scale, which is 0.6 millimeter. So we have a negative zero error 0.6 millimeter as our final reading. And for number 2, you can see that the 0 was on the left side on the main scale. So that means it is negative. And for us to get the value on the Vernier scale, we need to read it in reverse. So you see that the third line on the Vernier scale and the main scale is coincide to each other. So we have the value of the Vernier scale of 0.3 millimeter. So our final reading is negative 0.3 millimeter. Okay, I want you to find the zero error and correct the actual reading. You see on the first picture that the zero line was on the left side on the main scale. So it means it is a negative zero error. And the lines that line up on the main scale on the Vernier scale was on the third line on the Vernier scale. So we have the value of the Vernier scale, which is 0.3 millimeter. And like for example, we are taking a measurement which is the value on the main scale is 0. And the value on the Vernier scale, which is coincided to each other, is 0.6 millimeter. So we're taking a measurement of 0.6 millimeter. And when we are taking a measurement, we encountered a negative zero error. So how are we going to correct the reading? So what we are going to do is we need to add the actual reading, which is the 0.6 millimeter plus the negative 0.3 millimeter. So we have the correct reading of 0.9 millimeter. And for the example number 2, you see here that the 0 on the Vernier scale was on the right side on the main scale. So this means it is a positive zero error. And the value on the main scale that coincide on the main scale, which is the third line, is coincide to each other. So we have here the value of the zero error, which is positive 0.3 millimeter. And we are taking a measurement. For example, the zero line on the main scale did not reach on the first line on the main scale. So that means we have a reading of 10 millimeter. And the value of the Vernier scale, which is the sixth line, is coincide to each other. So we have an actual reading of 10.6 millimeter. And since we have a zero error, which is a positive zero error of 0.3 millimeter, what we're going to do is we need to subtract for us to get the correct reading. So for example, the actual reading that we're taking is 10.6 millimeter minus the positive 0.3 millimeter. So we have the correct reading of 10.3 millimeter. Okay, in this activity, I want you to get the correct reading or measurement of an object. On the first picture, we have the zero error, and the second picture, that is the actual reading of an object. So you see on the picture that the zero line was on the left side on the main scale. So that means it is a negative zero error. And for us to get the value on the Vernier scale, we need to read it in reverse. So, as you can see that the sixth line on the Vernier scale is good side on the main scale. So we have a negative zero error of 0.6 millimeter. And we have here the actual reading. As you see that the zero on the Vernier scale did not reach on the fifth line on the main scale. So that means our main scale reading is 64. And we have the value of our Vernier scale reading. You see that the third line is inside on the main scale and the Vernier scale. So we have the 0.3 millimeter. So 64 as a main scale reading plus the 0.3 millimeter. So we have that actual reading of 64.3 millimeter. So how are we going to correct the reading? Since we have a negative zero error, what we are going to do is we need to add the value of the zero error for us to get the correct reading. So as you can see that the actual reading is 64.3 and our zero error is positive 0.6 millimeter. So for us to get the correct reading, we need to add the value. So 64.3 plus the negative 0.6 millimeter. So we have the correct reading of 64.9 millimeter.